Hi there, we are working on the follow-up lecture 12 on our addition and subtraction integers. And I throw this one in here just to kind of summarize and transition. So in module 11, what we did was we said, okay, we want to model the operations of addition and subtraction of integers, meaning positive and negative numbers, using two different methods, using plus minus or colored chips and number lines. But once we do that, we want to work them into looking at patterns to identify generic rules that they can use to add and subtract integers when they don't have pictures. And so that's what we want to include today. So rules for integers for adding, we use the following rules to add integers using this shortcut. Okay, so if we're adding two integers with the same sign, so let's look at an example or two. So if we had -4 plus -3, right, I would draw 4 red chips and I would draw 3 red chips, and then we would count them all up, right? So that's if they're negative. If they were the same sign but positive, if we had, this is just regular old addition then, if we did 4 plus 2, then we would do 4 white chips and 2 white chips, and we would add them together. Okay, so in general, when we're doing addition, adding two integers with the same sign, we add the values, meaning the value here, meaning the absolute value or the value of the number without the sign. We add the values together. So the two pieces, we add the values together, and we keep the same sign, right? Whatever the sign was. So if they were red chips, we get red chips. If they were white chips, we get white chips. So that when I'm looking at -5 plus -2, I would take the values 5 and 2 and add them together to get 7. And I would keep the sign. In this case, they're both negative, so my answer stays negative. Okay, so that's adding integers with the same sign. What if we add integers with opposite signs? So let's look at a couple examples here. So let's say we're taking 5 plus -3. Well, I would draw out 5 white chips. So 1, 2, 3, 4, 5, and 3 red chips. 1, 2, 3. We represent both numbers. And then we would match up our 0 pairs and get rid of them. And I'm left with the 2 white chips. So when I match up 0 pairs, I'm essentially subtracting the value, right? Because those 3 matched up to some of the 5. So I'm going to subtract the values. And then how do I know what sign it should be? Well, this one's going to be +2, right? I have 2 white chips left. And that corresponds to the 5 because I had more white chips than I had red. So the more white chips means the higher value. And that's the colored chips that are going to be left over. So because my 5 is higher than the 3, I'm going to have more positive chips or white chips left over. And so my answer is going to be positive. So we keep the sign of the number with the largest value. Right? So for example, if we did -8 plus 14, right, we would, they're opposite signs, so we subtract the values. So 14 minus 8 this time is going to be 6. And then I look at which value is larger. The 14 has a larger value, and the 14 is positive, so I keep it positive. If we were doing -7 plus 4, I would subtract my two values. So 7 minus 4 is 3. And then which one has the higher value? The 7, and that one's negative, so we keep the negative. Okay, so that's what we do when we're adding. Not too bad. Two different sets of rules depending on whether we have opposite signs or the same signs. With subtraction, it gets a little more interesting, okay? All right, so subtracting integers with the same sign. Okay, so let's look at a couple examples. So let's see, what if it's with the same sign, and I'm going to stick with negatives because positives, well, maybe not. I'm going to stick with negatives for now. So let's take -8 minus -4, right? So what we would do is we would represent our first number. That's 8, so 8 red chips. And then this says take away 4 red chips. So we want to take away 4 red chips. And I'm left with 4 red chips. So this is -4. Okay. Now, what happens if I switch the order here? Because the order does matter with subtraction. What if I did -4 minus -8? Okay. That would mean that we start with 4 red chips. But I want to take away 8 red chips here, but I only have 4 red chips. So in order to take away 8 red chips, I'm going to have to add in 0 pairs. So if I add in 4 0 pairs, now I do have 8 chips, 8 red chips that I can take away, and I'm left with 4 white ones. So it's +4. So the order in which things are subtracted do make a difference here. So first, let's see, what did we do with the values? So in both cases, we had a 4 and an 8, and in both cases, we ended up with the answer 4. So what we're going to do is we're going to subtract the values. So subtract the values. And then how do we know what the sign's going to be? Well, notice that the sign of the first one, the -8 minus the -4, was negative, right? And we're subtracting things with the same sign. So when the bigger value was first, we ended up with the same sign. When the bigger value was second, we ended up with the opposite sign. And that's what's going to happen here. So if the larger value is first, keep the same sign. If the larger value is second, we switch the sign. Right? So if we have 2 quick examples here, let's say, now let's try positive ones and see if it works out the same way. So if we have 5 minus 3, right, subtract the 2 values. So 5 minus 3 would be 2. And then the larger value is first, so we're going to keep the same sign. So that's going to be positive. So it stays 2, which we know is correct. If it's the opposite, so what if we did 4 minus 7? Well, in this case, you're going to subtract the 2 values. So 7 minus 4 is still 3. But now the larger value is second, so we're going to switch. These are both positive numbers being subtracted, so we're going to switch to a negative answer. Okay, so it does work as a strategy. Okay, but it is a little bit complicated. Okay, which is why people struggle sometimes with these. Okay. Now, subtracting integers with opposite signs. Okay, here we go. Let's look at some examples. So let's say that we do opposite signs. So -8 minus 5. Okay, -8 minus 5 means I'm going to start with 8 red chips. And -5 means I want to take away 5 positive chips or white chips. I don't have any, so I'm going to have to put in 0 pairs to get them. So I'm going to add in 5 more 0 pairs. So 5 red and then the 5 white to balance them out as 0 pairs. So now I have my 8 original and 5 0 pairs. And then I'm going to take away the 5 white ones and I'm left with 13 red chips or negative chips. Okay, so we end up with that. All right, let's try one more. Let's try a positive minus a negative. So let's do 3 minus -2. Okay, so positive first, negative second. I'm going to start here with white chips and draw 3 white ones. And this says subtract -2 or minus, take away 2 red chips. Well, I don't have 2 red chips to take away, so I'm going to have to put in 2 0 pairs. Then I can go ahead and take away my 2 red chips, and I'm left with 5 positive chips. Okay. So notice that in terms of the value, we had 8 and 5 and ended up with 13. We had 3 and 2, ended up with 5. So when you're subtracting integers with opposite signs, we're going to add the values. Now, which sign do we keep? Well, in both cases, we kept the sign of the first number, right? The negative, the 8 was negative, we kept the negative. The 3 was positive, we kept the positive. So we're going to keep the sign of the first number. Okay, and that's what we did there. So if we had -2 minus 4, right? So you're going to add the two values together. That gives you 6, and you're keeping the sign out front, so -6. If you've got 10 minus -4, you're adding the values to get 14 and keeping the sign of the first one, which is 10. Okay. All right, so that's what we're doing. Like if we look at the chips of what we're doing, those are kind of the rules. And with addition, it's really not too bad, right? We kind of know how that works. But subtraction things, particularly when you're subtracting things with the same sign, it gets kind of tricky, right? So really what we can do is, because we have a good set of addition rules, notice over here that subtracting, particularly when you're subtracting with opposite signs, you actually end up adding the values together, right? And so really what we end up finding out is that our other rule for integers is that we can change the subtraction to addition and change the sign of the second number. And this is the rule that we want them to get to eventually. So when you do your solutions for me, you're not going to use this strategy, because this is where you want to end up with your students, right? You want to end up with this is what I like to call the add a line, change the sign. Because when you're doing -8 minus -2, you add the line to the plus sign and change the sign to something else. So now you're doing -8 plus 2, and of course they're opposite signs, so we subtract to get 6 and keep the sign of the larger number, so it's negative, right? So you're following the rules for addition, okay? But you're not going to do this yet. You're going to use your chips and your number lines and explain all that to me, because we want to build concrete skills before we go to the abstract rules.